Hello guys, I want to introduce you a new plot logging tool. So this is Plotjuggler. It is a plotting tool for ROS. I got a plugin extension. So I make a plugin for ArduPilot Dataflash logs. So I will show you how it's working. So you can see that the main program can accept different plugins to have many inputs. So you can use it for ROS and CVS data, for ulog, pix for ulog plots. And now we get support for ArduPilot Dataflash log. So yeah, it's a tool made by a geek. So you got a nice splash screen. So it's a CPP application, so it's quite fast. Okay, so I prepare some Dataflash log using CTL. It was a quite long log, so it's a dozen of megabytes, so it make a little time to parse. So here we go. So we got here every message that we got parsed. So we can see here every value. We can plot, let's say, altitude. So let's speed up a little. So next one is on the ground. So this is absolute altitude. We can plot, let's say, on altitude. We can put here, relative altitude. We can get, I don't know, but yeah. Okay, you see it running. You can see that all data are updated live. We can move everything and get all the data. So it's very classical. The main advantage is you can define many screens. So let's play it and do some latitude. So it's not very useful in these states because, okay, we got the latitude, they go up and down. It's not very graphical. Something useful on Plotjuggler is that you can do 2D plots like that. Hop. And now we got flat long plotheads, so we can see the trajectory of my drone that is doing basically a square around the CMAX field on theta. Sorry. So it's very convenient. And if you look at the yaw, you can see here we mostly don't move. And after we turn on position doing my square. So here it's quite difficult to see anything because it's not quite representative. Plotjuggler got a Lua scripting engine. So you can use Lua scripting to do math function on your plots, on your curves. So yeah, I will show you a small coordinate conversion. So I will go from time yaw to polar coordinates for the yaw. So I will transform the yaw using a cos value, and I will do the same for the sin, sinus. So I basically said, okay, I got a function that I can as input as a time and a value, and it's returning a value modified. So my value is modified by the sinus in radians of the value. And I did this for both cos and yaw. And so now if I plot it in with cos on x and sin on y, I'm in polar coordinates, and no, I got the right yaw. So I got the actual yaw of the drone as a plot. So it's quite nice. And we can see that my drone is doing some third turn at fast rates doing my square, and there isn't an issue. Okay, so that's pretty much all you can do like every plotting tool. So I hope you like it, and it will be useful for some people, I think. Thank you for watching, and have fun with it.